Okay, so what we're going to do right now is graph the tangent function, and then we are going to do one example with a transformation of the tangent function. We will graph the cotangent and an example with that tomorrow. First of all, before we start, the parent equation, which we're going to graph, is y equals tangent of x, or if you want to write tangent of theta, you'll see it in either way. Okay, the period of the tangent function and the range and all of that we're going to do after we graph it. If you want to take a look at your calculator to help, that's fine, but you should be able to identify some characteristics of the tangent graph. So I'm going to put tan x in. Do you guys notice that on the grid it goes from negative 2 pi to 2 pi? I'm going to do the same thing. So when I go in my window, I'm actually going to type in negative 2 pi to 2 pi. I also like to make a scale of pi halves. I'm not particularly a huge fan of the grid here because they don't do the 4 key points, they do 3. But we're going to just, at least the pi halves and 3 pi halves and 2 pi are on there, so we'll be good. Do you also see it goes from negative 4 to 4? So let's make our y min negative 4, our y max 4. Okay, so hopefully this kind of looks familiar from last year. This is the tangent function. And it looks like there's asymptotes, huh? Does anybody know where they are? Want to take a guess? So this is all the way to 2 pi here. This is pi. It looks like pi halves and 3 pi halves. Okay, but there's actually a reason why. Do you guys remember that when we were doing our unit circle stuff, we said tangent was sine over cosine? So the tangent is undefined when the cosine is 0, because that would make the bottom of the fraction 0. Okay, so I'm going to put here, when cosine is 0, then that would give us an asymptote. And thinking of the unit circle, okay, I'll draw it over here. The cosine is 0 at the top, right, which is pi halves, and at the bottom, which is 3 pi halves, so makes some sense there, right? If you went the other way, it would be also negative pi halves and negative 3 pi halves. I am going to use my highlighter. I'm not a huge fan. This is my xy axis, so let's do this. This is my xy axis. I'm going to just put my asymptotes on here. Like here's pi halves. I'm going to not do it this way. I'm going to do it with my pen. That's what I'm going to do. So at pi halves, there's an asymptote. And then another one at 3 pi halves. So would you make an asymptote at pi halves and 3 pi halves on yours? And going the other way, there's also one at negative pi halves and negative 3 pi halves. Okay. Now here's the deal. Once you get the asymptotes on there, in between the asymptotes, we're going to graph some points. Halfway in between the asymptotes, doesn't it look like it crosses the x-axis? So let's start in the middle. Halfway in between would be at 0, 0. It crosses the x-axis. Now, here's something else that's interesting. Halfway in between the x-intercept and pi halves is pi fourths. At pi fourths, it's a tangent value of 1. So would you also go halfway between your x-intercept and this? It doesn't have to be perfect because it's going to be in between 2 tick marks. We're going to just make sure that our curve goes through 1. And then I'm going to go halfway between the x-intercept and negative pi halves, and it goes through negative 1. And I draw a curve through it like this. Yeah. I probably will change it. I probably will just put the tick marks on next year and not the grid line, if I do find that. Alright, so let's do the same thing. Put your fingers on pi halves and 3 pi halves. Halfway in between there is that pi, isn't it? So we're going to make this cross the x-axis again at pi, and then we're going to do the same thing. Just go over halfway and up 1, halfway towards the left and down 1, and draw a smooth curve. And then I'm going to do one more. I'll go on the other side. Halfway in between negative pi halves and negative 3 pi halves is negative pi. And then I'm going to make those points also go through 1 and negative 1. Okay. Sometimes there's multiple ways you can state the domain, but now that we have the asymptotes, I think we can do that. Sometimes students like to start writing out the intervals and just use a dot, dot, dot to just say that it completes the pattern. For instance, if I started like this, dot, 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 negative 3 pi halves to negative pi halves, you could do it that way. Then there's asymptotes, which I indicate with a parentheses. And then the next one is from negative pi halves to pi halves. And then the next one is from pi halves to 3 pi halves. And just to show the pattern continues, I write dot, dot, dot on the other side. That's one way of doing it. Or you can just tell me all real numbers except, let's describe the asymptotes. Pi halves, 3 pi halves, what do you think the next one's going to be? Let's see, this is 1 pi halves, 3 pi halves, 5 pi halves, odd multiples of pi halves, right? Or you can just add pi onto pi halves, because isn't the difference between these a value of pi? So you could describe them. In fact, for my equations for my asymptotes, that's what I'm going to do. I'm going to write pi halves plus pi times k. And what that means is we start at pi halves and we can add on integers of pi. So I'm going to write where k is an integer. Alright, pick any two specific asymptotes on the graph. Let's see. Negative pi halves I'll pick, and pi halves. Alright, what do you guys think the range of this is? What's the range, bottom to top? Good. Negative infinity to infinity, there is no horizontal asymptote. And how long does it take for the cycle to repeat? Pi. Because from negative pi halves to positive pi halves is a total of pi. So actually the period of tangent is half that of sine or cosine. And we kind of talked about that before. In general, sometimes you might see this equation, y equals a tangent b x minus h plus k. To be honest, guys, I won't give you a ton of horizontal shifts and vertical shifts. I'll give you a, which just stretches those points, and b, which changes the asymptote. So I'm not going to really address the domain here except to say all reals except asymptotes, because it's going to depend on what the new asymptotes are. I will tell you the range is always going to be negative infinity to infinity. There will be never any horizontal ones. And if you want to figure out the new period, you're going to take the old period and divide by b. So I'm going to write pi divided by b there. And once again, I don't like to generalize the asymptotes because they're going to change based on the transformation. Here's the deal, guys. If you have an a in front, that vertically stretches the graph. It just stretches it. If I stretch something this way, is that going to change the asymptote? No. So if there's a number in front, you are still going to have odd multiples of pi halves as your asymptote, and you're going to just make those tangent graphs stretch, meaning these points would become higher or if it was a vertical shrink, they'd become lower. The only thing that would change the asymptotes is when there's a value of c, so that's the example I'm going to choose to give you. Okay, so flip over. We are going to graph, and we're going to identify the period and asymptotes of tangent to x. Okay. And the reason we're going to do the new period and asymptotes is because then that's going to help us make our graph. So what is b? 2. What this means is this has a period of pi divided by 2. The old period divided by b. What was the period of the parent function? Pi. It's half as big now, isn't it? Isn't this just a horizontal shrink of 1/2? Okay. So now let's just look at our old graph a second. If I shrunk these in half, if I took pi halves and I made them half as big, wouldn't they close in like this? And they'd be at pi fourths and negative pi fourths instead? So instead of, I'm going to just write this down, the asymptotes all get half as big. Half as big means like I multiply by pi halves. So negative pi halves times 1/2 is negative pi fourths, isn't it? Pi halves times 1/2 becomes positive pi fourths. 3 pi halves times 1/2 becomes 3 pi fourths, and so on. Remember before the asymptotes were at odd multiples of pi halves? Now where are they? Odd multiples of, what's on the denominator now? 4. Okay. So, let's sketch a picture of the graph. I am going to make 1 and -1 on here because the vertical points are not going to change. They're going to still be halfway between the x-intercept and asymptote. I am going to start by putting negative pi fourths, over here, and positive pi fourths over there. So that's going to be like my first cycle. And then I'm going to make that equally spaced to the next one, which would be pi fourths to 3 pi fourths. If I wanted to do the next one, it would be 5 pi fourths, because that's the next odd multiple. Okay. In between the asymptotes, it's the same. Crosses, 0, 0, and then halfway in between each of those points in the asymptote, they stretch up to 0. That would be like pi eighths 1 and negative pi eighths -1. So they are skinnier and flat, not as flat as before. So halfway between pi fourths and 3 pi fourths is an x-intercept. Halfway between the x-intercept and asymptote, we're going to graph 1 and -1 y values. I'll do one going back so I get 3 periods in. I'm going to go to negative 3 pi fourths this way. There we go. Y equals tangent of 2x. Okay, I'm going to have you do a couple graphs of tangents in your homework as well. So in 4 or 5.